Hey guys, welcome back to my channel. Today we're going to talk about the RSTP protocol, which is the Rapid Spanning Tree Protocol. Yesterday's video we discussed about the Spanning Tree Protocol and we saw that the convergence of the network takes a long time because it depends upon the BPDU timers. So today I'll show you how those BPDU timers take effect and how RSTP is used to solve this problem. Okay, so let's consider the same diagram as we considered yesterday. Okay, and let's see, we have let's say the link between switch A and the link between C goes down. Okay, so this goes down, right? So now what happens is we have another port on C, which is port 2, which is in the blocking state. So from blocking state, it will first it's gonna wait for the max H time. Okay, that is 20 seconds. In STP it is 20 seconds. It will wait for 20 seconds. After it waits for 20 seconds, it will be like, okay, now let me go from block state to listening state. Okay, it will go to listening state where it will listen for the BPDUs it receives from the switch B. As the switch B's port 2 is designated port, it is in forwarding state, so it will forward the BPDUs that it receives from the route A. And so blocking to listening take 20 seconds, listening takes 15 seconds. Then from listening it will go to learning. Learning is where it will learn the MAC addresses, and it will learn the MAC addresses of switch B and switch C, switch A and switch B, and this will again take 15 more seconds, and after 15 seconds it will move to forwarding state. So 20 plus 15 plus 15, right? So this goes from forwarding, right? That is, it becomes root port and this becomes block now, right? Okay, so it takes about 50 seconds to achieve this because of these timers, right? So here comes the RSTP protocol, which was actually developed by Cisco in order to tackle this problem of slow convergence time. So as a software developer, when you write these protocols, right, you create a protocol, you create a basic protocol like STP, and then you add more features to it and keep enhancing that feature. Okay, in every cycle you try to add certain features to make it better, or something like, STP was developed, on top of STP RSTP is developed. If you need a little more faster convergence time, if you can come up with something, a better algorithm, then you can create another protocol on top of RSTP. So this is what this is what generally all the computers, all the networking companies do. They keep creating features on top of the protocols. So now let's see how RSTP works. Okay, Rapid Spanning Tree Protocol. So in Rapid Spanning Tree Protocol, we don't have any blocked ports. Okay, instead of blocked ports, okay, we have alternate port and we have backup port. So alternate port over here is used like a blocked port. Okay, so now let's say, right, I have this as my root port, right? The same way it will elect the root bridge. Once the root bridge is elected, root bridge will forward its have all its interfaces in the forwarding zone, and then switch B and switch C will choose the root port and they'll choose designated port, and the instead of blocked port, this will be an alternate port which will be in discarding state. Okay, alternate port is like block port. Okay, it's like the second best port to the root bridge. Now there is also something called as backup port. Okay, backup port is basically, let's say, another connection to the root bridge from switch C. Okay, which will also be in blocked state. Okay, in RSTP this is called as discarding state. Okay, it is basically listening, but it is not learning. Okay, it does not learn and it does not forward any traffic. It does not learn the MAC address and it does not forward any traffic. So it is in discarding state. So this will be called alternate port, and this will be called a backup port, which is another port to the root bridge. Okay, so also there are other thing over here is there are two types of other ports. Okay, whenever a port is connected to a switch, it is called point to point link. Okay, but let's say if there is a host over here, right? Host C, then this would be an edge port. Okay, because this is not connected to a switch but connected to an end host. Okay, so this edge port will directly be put into forwarding state. It does not have to go through a Mac Sage listening, learning, etc. It directly puts it into the forwarding state. Okay, so this is just like two additional things, that is edge port and point to point link. Point to point link is the one which is directly connected to a bridge. Okay, it's the port between the two bridges. Okay, so now you saw how okay, now let's see. Let's say this link gets broken because of some reason. Okay, now what will the switch C do? Switch C will form its own new BPDU. Okay, it will say that it is a root bridge and it will send out of the alternate port. Okay, it will send out of the alternate port to switch B. Switch B will see that it is receiving a BPDU from switch A also and switch C also. Both are claiming to be the root bridge, but B knows that A has better BID, bridge ID. So B will immediately tell switch C that okay, no, you the root bridge over here has much better switch, which is switch A has much better bridge ID. So the switch A is a root bridge and not you. So switch C will acknowledge it and it will move its port to root port over here. Okay, since this has gone down, this will become alternate port. Make sense? So it does not depend on any timers over here. Okay, it's this process is extremely fast. It will send a BPDU to switch B saying that it is a root bridge. Switch B will compare that with the A's root BPDU and it will say that A is better, so you change your port to root port. Okay, and this C will change to root port and it will start forwarding the traffic. So there is no listening, there is no learning happening over here. Directly move to forwarding state, which saves like a lot of amount of time. Correct? It probably waits in the beginning, it waits for max age timer, which in RSTP is basically 3 into 2 times the hello message. Okay, so we wait for 3 retries for hello message to receive. If you don't receive it 3 times, which is 6 seconds, it will wait for 6 seconds and it will move to forwarding state. So comparatively it goes down from 50 seconds to 6 seconds, which is a huge improvement. So this is why RSTP protocol is used nowadays. Okay, now let me show you what happens in case if there is a new switch added. Okay, A, B, and I have C over here, and this is my D switch. Okay, this is my root port, this is my designated port, this is my root port, and this is in forwarding state. Okay, now let's say there's a topology change. Okay, and this is also 4, and earlier I didn't have this link. Okay, D is a new switch which was formed. Okay, and let's say that D is a new switch which is formed in the topology. It has a port which connects from C to D and also connects from A to D. Okay, A is a root bridge and D is a new switch, right? So what happens is A will send a BPDU to D with its own bridge ID with its priority and MAC address, and D will also send its so first what it will do is it will go to discarding state. Okay, both of them will be in discarding state. Okay, it will send a BPDU. A will send a BPDU, D will also send a BPDU. Once D receives the A's BPDU, right, D will realize ki okay, the A has a better BPDU, it has a more superior BPDU. So what it will do is it will first put this port into blocking state. Okay, This is called as synchronization. So this is to make sure that looping is not happening over here. Then D will send an acknowledgement saying that okay, yes, you are better. Okay, and I am going to be moving my port to root port. Okay, and what happens is, okay, now this becomes root port. Okay, now once this becomes root port, now there'll be a connect. Now the same thing will happen between D and C. D will send an acknowledgement BPDU to C saying that the cost to reach the root bridge is so and so 4. Maybe say this is also 4, or may let's say this is 3. Okay, and this is 4 and 4 8. So C will see that okay, to reach the root bridge this is the better path. So what it will do is, before before acknowledging it, it will first make this port, which is root port, as block port. It will block it. Okay, once it is blocked, it will acknowledge it and it will move to root port. Okay, and this will be my designated port. Okay, this will not be blocking anymore, right? It will be in discarding state, right? Okay, so I hope this made sense. Okay, now again, what happens once um, the switch, now again the same thing repeats between B and C. Okay, B will see that it's directly connected to the root bridge and it has better cost path towards the first interface only, so it does not care about the second interface which is going towards C, and it will say that it will not, it will, in the acknowledgement it will be like, no, it's not good enough for me, this is not the link I want. So C will immediately block this link. Okay, so if it's blocked, that means it is alternate port, right? Which is in discard, it's in the discarding state. Okay, it's basically block, it's not learning and it's not forwarding the traffic, but it is listening. Okay, so in RSTP we have max age of 3 into 2, which is 6 seconds. Okay, and the way these two work, right, is this is basically called proposal and agreement process, where they send each other the BPDUs, and before sending an agreement or acknowledgement, they'll block the other non-edge ports which are going to the other switches, which is called as synchronization. Okay, that process called synchronization, and using the proposal agreement, they'll directly form the root ports. Okay, they'll assign the root ports, so it does not again depend on the BPDU timers over here. Make sense? So in case it for STP protocol, we would have to we would have this forwarding delays, listening and learning, which was like what 15 plus 15 30 seconds for the network to converge. But in this case, it's directly sending and moving the ports to forwarding and deciding which is the root port, and then again sending BPDUs between other switches. The adjacent switches are synchronizing between each other and they are trying to reach an agreement, what's supposed to be the root port, which is supposed to be the designated port, which is supposed to be the block port. So this way, without using the BPDU timers of like 30 seconds, we are immediately converging the network, and hence this is why RSTP is widely used now. So I'll share a link with you guys. Please just go through it once. Look at all the states. Look at all this, the H port which I talked about, point to point link, and how the BPD, how the proposal and agreement work, how the packet looks like. You can find all of that information on a Cisco doc. I'll share it with you guys. So Cisco also came up with something for VLANs, which is called as per VLAN STP. That's again, a new enhancement or a feature on top of STP that is built. So yeah, guys, do let me know if you guys have any questions in the comment section. Please like, share, and subscribe. Thank you.